Let's look at some laws of indices. Before we even get in, let's define some things here. So let's say we have M, right? We're going to call M a base. Okay? Then we have A, and we'll call A our index or the power. Whatever word you're comfortable with using, yeah. All right, so we have a base and we have a power. That's important. All right, so number one, M to the power of A multiplied by M to the power of B. Now, if you notice, the bases are the same. So whenever we have bases that are the same, keep the base, and then we add the indices. So that's for multiplying. If you're multiplying the same bases, you're going to add the indices. So therefore, what will we do if we are dividing the same bases? We're going to do what? Subtract the indices. So it's the one at the top first minus the one at the bottom. Right? Okay, good. So let's look at another one involving brackets. Say we have M to the power of A all to the power of Y. So in this case, we're going to multiply the indices. This is when we multiply the indices. Okay? All right. And then here are some others. Anything raised to the power of 0 is 1. Anything raised to the power of 0 is 1. And then finally, anything raised to the power of 1 will be itself. And the last law that we're going to look at is something with a negative power. So let's say we have M raised to the power of negative P. This means that M belongs in the denominator. So another way we can write it is M to the power of P. All right, now let's look at two examples that will incorporate, if not all, then most of the laws of indices that we just looked at. Okay? All right. So we're going to start off here. Simplify 3p squared multiplied by 4p to the 7th power. All right. So let's look at the numbers. Right? 3 times 4 will give me what? 3 times 4 is 12. So if we combine the numbers, we have 12. Then we have p squared multiplied by p to the 7th power. And if we look back here, if we're multiplying like bases, we add the powers. All right? So let's do that here. So we put the 12 back. The base stays, and 2 plus 7 gives us 9. No, there's no cancellation. That's it. All right, let's look at the second one. So in dividing fractions, what's something we definitely know we should do? Whenever we divide fractions, it's going to be 3x over 4y cubed. We're going to do what? Multiply and upturn the second fraction. So we have 20y to the 4th over 21x squared. All right, now whenever we're multiplying, we can actually do some cancellations across. So let's look at it this way. 3 into itself once, 3 into 21 goes 7 times. All right, and 4 into itself once, 4 into 20 goes 5 times. So far, I'm going to rewrite this. All right, we have x multiplied by 5y to the 4th power all over y cubed multiplied by 7x squared. Okay, here's an idea. We're going to combine them. All right, now I can just multiply the top and I get 5x y to the 4th. Why the x first? Because, alphabetical order. We keep them in alphabetical order. Then down here we multiply, we get 7x squared y cubed. Why? Because unless the bases are the same, we're not going to be adding that 2 and 3. Now we can actually look at something here at the side. So we have x to the first power divided by x to the second power. And what did this law say about dividing similar bases? You subtract the powers, right? So it's going to be x to the 1 minus 2, which is x to the negative 1, right? So we have here 5 over 7. I can bring down the 5 over 7. And we have x to the negative 1. Let's work out the y powers now. We have y to the 4th divided by y to the 3rd. And that's going to be y to the 4 minus 3, which is y to the first power. Anything raised to a power of 1 is itself, so we can just put y. And let me just section this off, which means this is going to be 5 over 7 x to the negative 1 y. Or, according to the other law, it will be x will go in the denominator because it's negative, so we can even have 5y, y the power is positive, which is positive 1, at the top over 7x at the bottom.